Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video.
Now, as you know that whatever examples I am adding into the course of Exergic, each and every example is adding some value. It is teaching you something more about the concept. It is improving your numerical solving skills. Merely knowing the concept is not enough, because when you have to implement that concept in any numerical, in any situation, that will make you actually make that knowledge useful and make you successful. Let us solve one more question on the similar trend. This is such a question which ideally you should be able to solve in less than 2 minutes or maybe 3 minutes. But many students, many aspirants can make mistake, because how to implement what you know, that is also important. You will learn some useful things from this question. Let us start the question. Question says that an open cylindrical bucket 30 centimeter in diameter and 50 centimeter long, or 50 centimeter is the height of that. So it's a cylindrical bucket and it is open from one end with negligible wall thickness and weight. Okay, its mass is negligible and its wall thickness is also negligible. The thickness of the walls you do not have to consider. Is forced into the water with open end first until its lower edge is 10 meter below the water surface. For this case, since I cannot use a bucket here, but I have arranged a mug, a small mug. So assume this is the bucket, okay, and there is a big water body, there is a big water surface. This is the free surface, okay. What question is saying that this bucket is forced into this water, as you can see, with the open end first, right? Not like this. This is the closed end, not this, but in this manner, open end is entering first, right? It is forced into water until its lower edge is 10 meter below water surface. So you keep on pushing down and down and down and down until its lower edge is 10 meter deep. This is the lower edge, right? This is the lower edge. This is 10 meter deep, okay. The force required to maintain this position is how much? You have to push it like this, and then you have to tell that how much force you need to apply to maintain it into this position. To understand this question, that what exactly is happening, you need to have, means it will be better if you have a feel of what is happening. I can tell you this from my childhood, that in the bathroom, in some of the days while taking the bath, it was a fun activity. That you have the bucket in front of you, this is the mug, you have the water in the bucket, and try to enter this mug like this and tilt it. What happens after that? Suppose this is the bucket, okay, suppose this is the bucket, this is the mug, and I am pushing this mug into the water and I am tilting it. What will happen? Bubbles will come out of it. As a child, it was a fun activity sometimes. If you have not tried it, you can try it right now also. This activity can be performed by anyone. Even sometimes as a kid, I used to do it with my hand as well. You push your hand like this, there will be air pocket trapped inside, and you tilt it, bubbles will come out of it, right? As a kid, you can understand it is fun to watch bubbles, right? You can try this activity actually. I will recommend you to try this activity, because to have a feel of this question, it will really help you to perform this activity using a bucket and a mug. So take a bucket of water, insert the mug with open end first like this. Two things to notice. First is you tilt it and bubbles will come out of it. What does it tell you? It tells you that air is trapped inside this particular mug, right? That is why bubbles are forming. Air is coming out in the form of bubbles. Second thing to notice is that initially it will be very easy for you to push it inside. But if you try to keep pushing it down, it will become more and more difficult to keep pushing it. And if I ask you that push it such that you touch the base of the bucket, trust me, it requires a good balance and a force, right? To push it such that you keep it touched to the bottom of the surface. In this question, what is happening? There is a bucket, right? Inside, instead of a mug, you have a bucket. And instead of the bucket, you have a big water body. Right? You can understand 10 meter is the depth up to which you have to immerse it. Right? Your bucket is very small. So for this case, we have a big water body and a bucket is pushed into like this. Right? And as you keep pushing it down and down and down, it will become more and more difficult for you to push it. Why it will become difficult? You will understand very soon. When I will be solving it, obviously I will explain it. So two things will happen. Air which is present inside this bucket while moving down will get trapped into it, right? It will have no way to escape, because what is happening? At this point, it is totally air inside, right? And as you force it into the water, that air will be trapped inside. The air inside does not have a place to move out, and you keep pushing it down, and that particular air pocket, this is air, will keep moving down. This air will keep moving down as you push this down. As a result of that, what is going to happen? Let me tell you. Look, initially air will almost be completely filled into the bucket. But as you keep moving it down, what is going to happen? The pressure is going to increase, right? As we move down, the pressure inside the fluid is going to increase. That pressure is also going to act at these points, right? Which are present just below the air surface. And when the pressure of those water particles will be more than the pressure inside, what is going to happen? It is going to push it inwards, right? These water molecules will start getting pushed inwards. As a result of that, the bucket which initially was having fully air will now have a certain region of water as well. It will not happen in your home experiment of bucket and a mug, because how much is the height of bucket, right? So pressure will not be that high. But when you will start doing it in such a situation, when you will push it down 10 meter deep, these things will happen. So what is happening actually? The fluid, the water which is at higher pressure is going to push the air inside due to high pressure. As a result of that, the air will also start getting compressed. The pressure inside of the air, this pressure will also keep on increasing. And this water will keep pushing it until this pressure becomes equal to the pressure of the fluid, which is increasing. You getting my point? So at any given position, whatever is the fluid pressure being exerted, that fluid pressure will help the liquid or the fluid getting into the bucket, and as well as it will help it compressing the air. The air will also get compressed. Okay. Question is asking you, coming to the question, I have not started the question yet. Assume that the air trapped undergoes any change under isothermal conditions. So this compression of air, compression of gas is happening isothermally at constant temperature. This you have to assume. And assuming this, you have to tell that how much force is required to maintain this position, right? Again, I will recommend that please take out 2-3 minutes of time and perform this activity. You will feel that yes, a force is required to maintain it. When you keep pushing it down, you will require a force. And this is happening because air is trapped inside. If this was completely water inside the bucket or inside the mug as well as outside the mug, and if you ignore the mass of this bucket or this mug, then there will be no buoyancy. Ignoring the mass, I am telling you, because if there is no mass, it will not have any volume, it will not displace any liquid, there will be no buoyancy, right or not? That is why if fluid is present inside as well as outside, there will be no force acting on that particular mug, because weight we have considered negligible, with negligible thickness and weight. So weight is negligible, so no weight, no force acting in the downward direction, and thickness is negligible, so it is not displacing any volume, negligible volume of water it is displacing, so buoyancy will also be negligible. So if water was present inside as well as outside, then there will be no force required to maintain it, right? If instead of pushing it like this, if you tilt it and then you push it down like this, what is going to happen? Water will get into this, right? So completely it will be filled with water inside as well as outside. There will not be any force required to maintain it. But in such case, when air is trapped, things have changed now. So two things you have to do at this point. Try this experiment. It will really give you a good feel of the question and of this concept. And secondly, try to solve this question. I am continuing this question, but please make an attempt to solve this question. You may make some mistake here and there, and I will address those mistakes without even looking in your notes. I will tell you where you will be making mistakes, right? And how to avoid that, and what is the correct way of solving this question. Let us continue. So I have drawn the diagram for the given question. You can see this is the bucket, this and this inverted bucket. Air is trapped inside it. Some water has entered into it as a result of extra pressure or more pressure surrounding it. It is at a depth of 10 meter. The lower edge is at a depth of 10 meter, as it says, its lower edge, right? And its dimensions, 0.5 meter long, 50 centimeter was written. I have converted that to meter. Its diameter is 30 centimeter or 0.3 meter. This is the diameter. Okay. Now tell me, how are you going to proceed with the question? Let me tell you what confusions different aspirants may have, or what approaches they may have applied. Some of the students, what they have done is that they consider that, sir, this is the air trapped inside, right? This is just like a mass. Some of the students can think of this. This is a wrong approach, but some of the students may think of it that, sir, this is air trapped inside, it is like a mass, right? And just like we apply the concept of buoyancy for any mass which is immersed into the liquid, that net upward force will act, which is equal to buoyancy. So we can apply the buoyancy concept here, and as a result of that, whatever is the net upward force, that much force we need to apply. This is one approach that some of the aspirants can apply. This will give you an incorrect answer. Let me tell you why. Recall the derivation of the formula of buoyancy. What did I tell? That net forces acting on any body from upward direction and from the downward direction, their difference will give you the buoyancy force, because this force will be more and this force will be less. So their difference will be a net upward force, which is going to be buoyancy. In this situation, this force, pressure force acting from the down, has only one effect. What was the effect? To apply the force in the upward direction so that the mass can move upward, right or not? This force was not having any other effect. But look at this situation. If you consider that this is a similar mass, a mass of air, and if you start applying the funda of buoyancy, you start finding out the force which is going to act from here and the force which is going to act from here, you take their difference, which exactly is the formula of buoyancy, and then you will say that this is the net upward force, and that much force we need to apply in the downward direction on the bucket to maintain it. It will be wrong. Why? Because this upward force which is acting here, this upward force does not have the effect like this upward force. Why? Because this upward force was only trying to move it up, but this upward force also has a role in compressing the air. This upward force is, some part of this force is also used to compress the air. So this mass is not similar to this mass. This was not a compressible mass. This was an incompressible mass. So this force which was acting was having the sole effect of movement in the upward direction. But here it is not the situation. Here this pressure is also used in compressing the air. So do not apply the formula of buoyancy in this case. the basic conceptual difference between the formula of buoyancy that we use, I have told you here. So you cannot apply this formula here, that I will use the difference of these forces, or I will directly use the buoyancy acting on this volume. How much air has displaced, that much volume, how will be the buoyancy force? Equivalent to that much volume, I can find out, and that will be equal to net downward force required. No, it is an incorrect approach in this case. Okay. Now, some of the aspirants, what they can think, that sir, this bucket is open from the bottom, but let us assume that the bottom surface is closed with a thin layer of water. So this is a complete mass, and let us now try to apply the buoyancy funda. That funda will also not work. Why? Look, if you consider this lower part, how much is the weight of it? The weight of the lower part is equal to the weight of water itself, right? It is water displacing water. If you consider this whole part as a mass, then the lower part, this part, is filled with water only. So it is effectively water which is displacing the water. The downward force is weight of that water. Upward force is weight of the water displaced. Both of them are same. So no effective upward force is acting in this part. So this imagination will also ultimately lead to only this part, because bottom part is useless. Net downward and net upward force are same. And we have already discussed that if we consider only this part, it is not going to give you the accurate answer. So these approaches are incorrect. Look, whenever you have such questions, think with the utmost basic concepts. What is the most basic concept here that you can apply? The free body diagram of the bucket. You have the bucket, you are applying the force on the bucket to keep it maintained. You are not applying force anywhere else, on the fluid or on the air pocket. Directly you are not applying any force anywhere, you are applying force only on the bucket. This is the bucket, right? You are holding it down, applying a downward force on the bucket. What are the other forces acting on the bucket that are making it move upward? That you have to consider. That's it, right? And that effective upward force you have to apply in the downward direction. Now tell me, what are the different forces that will act? Let us first consider the curved surface of the bucket. For this, let us consider this curved surface. Whatever is the force acting from here or from here by the liquid, both the forces are acting in the opposite direction, right? They will cancel out each other. Whatever force acts from here, same will act from here. And this will happen around the periphery, on all the sides. Correct or not? Because fluid is present all across the curved surface. So forces along the curved surface, forces acting on the curved surface, they are not going to be considered, they will not matter. And anyway, we want to find out force in the vertical direction. So why will we consider any horizontal force? So let us remove all the horizontal forces and forces on the curved surface from the picture. Only vertical surface. Okay. Vertical forces which will be acting on this bucket, very first is air. From the inside, if you look, air is present inside, and this air is not at the atmospheric pressure, right or not? This air is getting compressed. This air has developed a pressure because it has been compressed. So there is effective upward pressure force acting on the bucket, on the base of the bucket from the air. Correct? Obviously, pressure force will be acting in this direction from the fluid also, because fluid is touching the base. So pressure force will be applied there. What about the pressure forces here on this part? Here or here? Will any pressure force will act here? On the edge, on the circumference, on the periphery? No. Because question has given that it is having negligible thickness. Wall thickness is negligible. So you do not have any area present so that a force can be applied there. So no pressure force is acting here. Only consider the forces acting on the bucket. These forces are not acting on the bucket. They are acting on the air, right? They are compressing the air. They are increasing the pressure of the air. And that pressure is obviously acting on the bucket. And we have considered that. But this pressure we are not going to consider. It is not acting directly on the bucket. So this one will not be considered. And also, As I was telling you, these forces, if you think that on this part of the bucket, on this part, some pressure force will act. So this thickness has been given negligible. So there is no area for the pressure to be applied. So that force will effectively be zero. So no forces are acting from here also. These are the two prominent forces acting on the bucket. One by the water available above the base area, another by the air available under or below the base area. Net upward force you find out as a result of this. Whatever is the net upward force, the same force you need to apply in the bottom direction to keep it stable. Question is not over yet. There are some more learnings from this question. Make sure to listen to me till the end. So this has a net upward force which we will check whether it has or it does not have. And that much net upward force we need to apply in the downward direction to balance it all. Correct? Let us start solving this question. What do we need to solve this question? How to proceed in this question? This pressure which is acting by the fluid on the surface, you can find it out very easily. Why? This depth is 10. This is 0.5. So this depth effectively is how much? 9.5. 9.5 meter. Right? Very easily you can find out that pressure. But what about this pressure which is acting from the inside, from the air which is trapped inside? How to calculate that? Question has given you that air undergoes the compression isothermally at constant pressure. So whatever is the pressure and volume initially and finally, they will be related by the ideal gas equation at constant temperature. Air we can assume as the ideal gas. For isothermal process, PV is equal to constant. So we can apply initial pressure, initial volume is equal to pressure here and volume here. Correct? The thing to notice here is that initial pressure of atmosphere you cannot take as zero. Why? Firstly, question has given you atmospheric pressure. Logically think there will be some use of this pressure. And even if you think conceptually, you will understand that in ideal gas equation we have to put the absolute values of pressure and not the gauge values of pressure. So for the atmospheric pressure, if you put 0, then P1 V1 is equal to 0 does not make any sense. So you have to write the equation by considering the absolute pressure. The dimension of this bucket, it is written here. Initial pressure or atmospheric pressure P-atm or P0 is equal to 100 kilopascal. At that state when it is compressed, let's say the P1 pressure is the absolute pressure of the trapped air inside. And X tells you, this X tells you that how much, up to how much depth or how much height or level the water has entered into the bucket. For the isothermal compression as given, if we apply P0 V0 is equal to P1 V1, what we will get? Initial pressure 100 kilopascal, volume pi by 4, d square, diameter is not changing. So d1 or d0, d1 we don't need to write, just d1. Area multiplied by how much was the air initially? Full bucket was air, right? So its height or length was 0.5 meter. This is the volume, area multiplied by height of the trapped air initially at atmospheric pressure is equal to P1, the pressure right now. This is the value of P1 multiplied by how much is the volume now? Pi by 4 d square multiplied by this much height. How much is this? 0.5 minus x. 0.5 minus x. This and this will cancel out obviously. So in this equation, this term and this term are gone. So what do you have? 100 multiplied by 0.5 is equal to P1 multiplied by 0.5 minus x, right? This is the first equation that you have got. What is the other equation that you can find out? Why you need to find out the other equation? To know the value of P1, you need the value of P1 so that you can calculate the net upward force. But x is an unknown. We can write one more equation here in terms of P1 and x by equating the pressure at these points with the pressure at these points, right? Both of them are at the same level in the same fluid. What will be the pressure at this point? Very easy to find out. Initial means atmospheric pressure P naught, that also you have to consider because we are writing absolute pressure. So P naught plus rho g, how much will be H? 10 minus X, right? So P naught plus rho g 10 minus X will be the pressure at this point. How much will be the pressure at these points? Pressure will be equal to P1, the pressure of air itself. I have already told you this funda, that how to differentiate between the pressure variation of a liquid and of a gas. Since gas is present here, air is present here, so pressure on the top and bottom sides or top or bottom surfaces will be same. So at this point P1 pressure is present, so is equal to P1. Now if you put the values, P naught is 100 kilopascal, right? Rho is 1000. Since this kilopascal will be having multiplied by 10 raised to the power 3, this will be having 10 raised to the power 3. So I have cancelled them, and now P1 value what we have will be in kilopascal, right? Because this equation is written in terms of kilopascal. This equation also in terms of kilopascal. 100 we have used directly, kilopascal we have used directly. So here also pressure will be in kilopascal, right? So remember this, that whenever we get the answer, it will be in kilopascal. It is possible to do these small mistakes in units. Now you have equation 1 and equation 2, both are having P1 and X as unknowns. So you can find out P1 from here, 100.5 divided by 0.5 minus X, and put that value here, right? And you can solve it. It will give you a quadratic equation, right? Because this term will be multiplied to 100 and then multiplied here. It already has 10 minus X, so upon multiplication, you will get this quadratic equation. And when you solve this quadratic equation, you will get two values of X, 0.244 meter and 20.449 meter. Out of these two values, this value cannot be possible. The value of X cannot be more than 0.5, correct? And in this case, it is coming out to be even more than 10, even more than the depth. That is not possible. So this is the value of X that we have to use. And now you have two equations. In any equation you put the value of X, P1 will be the only unknown. Calculate the value of P1, 195.701 kilopascal will be the value. So you have successfully calculated the pressure acting on the inside surface via compressed air. So after calculating the value of P1, we can easily find out the net force acting in the upward direction. The force in the upward direction is P1 multiplied by the area from the inside. Since thickness is negligible, so whatever diameter we have is the external as well as internal diameter, right? So this diameter is 0.3 meters. It was 30 centimeter. Okay. You put the values and you will get this answer in kilonewton, because this pressure was in kilopascal. Small things to notice, but since question is asking you the force in Newton, you need to be careful about the units. So this is in kilonewton. Similarly, the force acting on the top surface via fluid will be how much? The pressure, hydrostatic pressure. How much will be the pressure? P naught plus rho gh. You do not have to forget about P naught here, because generally in questions we have a habit of considering direct rho gh, because all the calculation maximum are in gauge pressure, but this one is not in gauge pressure. So do not forget to add P naught, which is 100 kilopascal plus rho gh. How much is this height? It is 9.5 meter, as I told you earlier. And what we can write, that pressure at this point, let us say this is P2, is equal to P naught plus rho g h2, this one. And since it is in kilopascal, it is in kilopascal, so this rho, which is 1000, we can remove, so that we can divide it here and here, and now they are in kilopascal, kilopascal. So this is the equation to use, means P2 in kilopascal, or this one, this term here, this is P2. This is equal to P naught in kilopascal, which is 100, plus GH2. G is 9.81, H2 is 9. That direct value we are using of P2, which is in kilopascal, since 1000 has been divided, right? Same funda as we used above. So this multiplied by area, pi by 4 d square. Since this is in kilopascal, you will again get the answer in kilonewton. You can clearly see that upward force acting is more as compared to the downward force. So net upward force will be the difference of them, P1 minus P2, or the force F1 minus F2. So if you do that, F up minus F down, you will get 0.176. 13.833 upward force minus 13.656 downward force. This is in kilonewton. Convert that to Newton. This is the required answer, 176 Newton. So I'm sure this question gave you a very good clarity regarding how to solve the questions where there is free body diagrams involved like this, where there is compressibility involved, where there is some air trapped inside, and many more such questions can be framed. Using the same concept, we can make many more such questions. We can change the shape of bucket, we can change the situation, but basic concept is not going to change. All right.